Hi guys, we're at Furch Guitars in Czech Republic, and we're with Petr Furch, and he's telling us some good stuff about like voicing process of the tops and CNR system of the necks, which is kind of revolutionary in my opinion. Would you might tell us a little bit about the neck?
About the neck first?
Yeah.
Okay.
Because it's right. It looks really like kind of futuristic.
Oh, it is.
Maybe show
yeah
people.
Okay. So
you see lots of metal in acoustic guitar neck.
yeah, metal is not the important part, but the carbon is.
Right.
So this is our CNR system. It stands for composite neck reinforcement. How does it work? You see this, this end part over here.
First question: is it this normal truss rod without all the additional stuff you added?
Exactly.
Right.
This is the standard two-way truss rod.
Okay. Just turn around, turn loose, tighten the neck.
Yeah.
All right. Okay.
Both direction, so you can put concave or convex direction.
All right.
That's how it works, and this is very common to use in a guitars.
Yeah.
So, but usually, including ours, we used to do it like that. We fit this truss rod into the wood itself.
Right.
But what we had a problem with is that it applies its tension only at the beginning, at the end.
Because it's tightened there, right? You just screw it.
It's not really tightened,
Okay.
but it's just that's the way how the truss rod works. So
Yeah,
it
you
really
compress it, right, and it bends.
You compress it, then
Okay.
it bends
Right.
and pushes, but the end only beginning at the end.
Okay.
And the problem is that then what is in the neck here between here and here is the wood.
Right.
And the wood is actually quite unpredictable material.
It's
nice.
grown, right? So every piece is kind of different.
Exactly. So every piece is different, and it grows, so it has certain tension inside. While you are drying the wood, or if you just have a humidity change.
So you can erase that tension problem with a good drying process. It will be there.
We've tried it. We've tried really long dried wood, but it still has this tendency to.
Okay.
Let me put it this way: if the wood is in the solid form, like in the neck it is, and the tensions are very difficult to take away.
Okay.
So what we were thinking is that how to make the wood behave as we want,
like in a stable way.
Yeah.
Okay.
Exactly.
Okay.
Guitar on a guitar neck, you want to have a nice neck relief, very smooth neck relief.
Yeah.
So what we have done there is we fitted this truss rod into the carbon pipe.
Okay. So carbon.
And what happens there? Do you know?
Well, I think the pressure will be like on the whole truss rod because the carbon is so stable.
Yeah, carbon is very stable. That's right, and very rigid. So when you turn the truss rod, then you apply the tension not to the wood, but first to the carbon pipe.
And this
and that is making very nice neck relief.
So you just kind of separated the pressure from the wood and put it to the carbon. And
first to the carbon.
Okay.
And then we glue the carbon inside into the wood, completely attached to the wood. Okay. And so it's basically forcing the neck to behave the way we want.
So like you implant you into the wood. It's like it's one element.
That's very important part because you have to really glue it in, it's attached, so it doesn't go off the carbon pipe. I mean, so this is very important. So then we were able to make this wood, this mahogany part and ebony part, to behave with a very civilized manner for a guitar player.
So you know where it goes when you attach the ball, right? It's always the same.
You have great neck relief. So that's one part.
Right.
And the other part is this cast element. Actually, it's a metal part.
What is this?
This is actually holding the angle of the heel.
Okay, so there's no movement in the angle to the neck.
We want to reduce the movements because you have to imagine you have the strings here.
They pull.
And so you had a factory tour. So do you remember how big is the length of the strings?
The 72 kilograms?
That's right, about 72 kilograms. Cool. So 72 kilograms you have over here. Yeah. And if you imagine the leverage is very big.
All right.
The size of the heel in a guitar, because all manufacturers, we all want to have the heel as small as possible, so it doesn't restrict your reach to the high positions. we have a small heel, and to really make this neck and body joint rigid, you have to make a big block inside.
Okay.
But big block inside means that you're basically muting this area
because
of the body.
There's no vibration. It's like too much wood.
It's just a big block here.
Okay.
Because it has to be rigid, and if you want to have if you want to use wood as this rigid structural element, it's you have to use a really big block, which is the dovetail system, which is very common. This is actually a solution, but when we fitted this cast element here, we were able to move the structural part from here to just here, to move it inside of the heel. So
this one keeps all the tension and pressure. Okay.
So of course we needed to reinforce this area in the body as well, because it has to hold it. But we don't have to use the big block, and we have designed this area so it can actually move and it can still resonate.
How you come up with that idea?
It was actually many ideas coming together when we were thinking with individual problems which guitar neck has. We were talking about it with my father many times, tried the different things over the years, and we just came with we just tried someday to use the carbon pipe, but the carbon pipe itself didn't work well enough for us.
Okay.
So we still had some sort of movement, and then we said, okay, it's a pipe, so we can really fit it into some sort of element like this, and make it even more rigid, and it was
so it's like every little day thinking about guitars and a little bit tweaking there and modifying here.
Yeah, that's very common way how we work. So it took actually about 4 years for us to from the first idea to get to that point that we were able to put it in a production.
Is it in every guitar?
Yes.
All right. So
not every guitar, but it's going to the entry level Violet series. It's still there.
All right.
But the guitars where it is not is Little Jane, obviously, because it doesn't have a heel.
Another mechanism. Yeah.
But I should say that the carbon pipe in Little Jane is there.
When you think about your 10 days work time a day, 10 hours work time a day, how much time do you spend in thinking about guitars and improving stuff? Could you say, oh, it's 1 hour or two? It's like on my daily thinking is how can I make guitars better? Is there a average time? Or is it just like while having coffee at breakfast, I got a good idea?
It depends what kind of role I'm taking at the moment.
Okay.
Because I have many roles. I can be an engineer.
All right.
I can be a sales guy. I can be a marketing guy, and I have to be also like a CEO kind of person. So I have to take different roles, and depends what There are some times like 2 months in a row that I mostly have to be more like a marketing guy, and there are times like can be half a year that I'm also like an engineer.
What's your favorite role? Engineer, guitar builder?
I like my roles to be balanced. Because naturally I am more like engineering mentality. That's what when I started with guitars when I was 21, I didn't have ambition to be a guitar builder. With my father, because he was doing business and didn't have so much time to spend with us kids, so we didn't have the best relationship because we met only because if I had some troubles and so on. It's not a complaint.
I know these moments.
It's like this. So, but I didn't really think about joining the company really doing the job what I'm doing right now. But I asked my father if he can give me the job, because I, of course, with my guys, my friends, I had to make some money to have a beer and have fun. Very
stuff to live.
Exactly. So I asked him to have a job, and because I was a musician, I was able to work in a final stage, like pulling the strings on, fine tuning, the setup, the neck relief, and so quite quickly realized that I like this, like kind of improving stuff, because I was started to think. It came naturally to me actually that I was started to think, okay, we could maybe do this different way, and so it would be maybe better. And I came to my father and I said, cannot we do it this way? What do you think about it? And he said, well, let's try it. And he was very open to that approach.
So you're grown into.
And when you do something like that, and when you have some idea how to improve something, somebody lets you do it, and it actually brings the result. It became. Yeah,
you're motivated for another good idea.
It's a great motivation. Yeah, exactly. So that's how I realized that I'm more like a technical guy.
Okay.
And actually from that point up till now, I'm still going this direction. Of course, as a CEO of the company, I need to learn different things, but to be honest, this is also very, very interesting for me, because it's a challenge, and it's definitely. And I must say, I like if it's not too much, then I like all roles of my everyday life.
That's really good. And talking about good ideas, we got another piece of wood line over there. It's a top with a X bracing. Let's talk about your voicing process. So we have a top board here, right? Looks very simple.
Spruce top. Yeah. Some pieces of wood, nothing too sophisticated.
Okay, right. Okay.
It's nothing too sophisticated. It looks like that, but a very important thing is that let me put it this way. It's you have to divide it in two parts. One is the top board itself.
Yeah.
One is the bracing. Two parts. Altogether, they are basically the most important parts influencing the sound. Right. It's very important to work with.
What do you say? How much percent of the sound is coming from the top? 80, 90?
It would be in that range.
Okay.
It would be majority, because the size of the body, then the body shape. You can alter the sound, but everything starts over here.
All right. So if this doesn't work, so the whole guitar doesn't work, right? Okay.
Yeah, and so we pay great attention to these parts. So if we talk about bracing itself, we design the bracing for every body shape. So Grand Auditorium has the certain bracing. Body shape.
All right.
Dreadnought has certain certain bracing pattern, and Dreadnought has a certain bracing pattern, and so on.
Right.
What is interesting about bracing, that they look quite simple to make, but if you do the copy, you wouldn't have the same sound result, because we work a lot with preloads. And so we apply certain, we glue the tops in a certain preload.
Okay, so it's like kind of tension to the flat?
It's kind of artificial tension we put in, which is necessary for to work with a guitar like that. But very interesting is the top board itself, because it works as a sort of like a membrane of the speaker.
It's moving, right?
Yeah. It's as I said, it's a very, very similar a function as the speaker of the as a speaker membrane. Again, this is made of wood. Very unpredictable material.
Like we said,
but it has its characteristic in a sound, and to be honest, I like the wood sound very much. We've been playing with different alternatives in our research and development, but wood it's
not to beat. Okay,
I don't think it's gonna be beaten. But anyway, what we do, how we work with this natural volatility of the spruce. We basically take every single top individually. We let it go through a certain process of measuring, and by changing the thickness, we adjust the thickness basically.
So the flexibility,
the physical properties. We adjust the thickness, and we do it actually in a different, nowadays we are able to do it in a different areas, in a different thickness. You don't see it here, right? But it's really there.
To make it clear, this area could be thicker than this.
Yes,
depends on how the wood behaves in the meshing.
It could be like this could be, for example, 3.2 millimeters.
3.5.
Yeah, this could be 3.5. This here in this area could be 2.5. This could be 2.8.
Okay.
This is decided by our measuring, and then we have certain steps to achieve the sort of sweet spot which we have isolated
so you just tune every piece of wood to that like fixed sweet spot. All right. Okay.
That's our goal.
How long does it take? Roundabout.
It depends on the wood, right? It depends on the individual, because the step is like, okay, we measure the wood for the beginning.
Right.
Then we have to do certain step to get it to the certain point, and then we have to measure again, and it can be quite various time,
Okay. So maybe the first thing is good, so just need a little attachment, and the other one is like, okay, we need to go there, there.
It could be 5 minutes to 20 minutes, roughly.
Okay.
But we have already developed this process quite a lot from the beginning where we started it with it. So this is very important because otherwise you would have a model like our Yellow Series Grand Auditorium with cedar top, and every single piece would sound quite different.
Quite different, not just a little bit.
Not just really a little bit, but quite different if we don't do it. That's what we found out many years ago, and that kind of forced us to do this.
Okay, so just get a little like a little even sounds. Each guitar should sound kind of similar.
Yeah.
Okay. Depending on the model, right?
Of course, depending on the model, but still, if we are tuning for the voicing. If we are doing this, we always going in the same speed spot.
Okay. So
but we achieve great reduced tolerance between in this output, sound output of our guitars, so and this is very helpful.
Okay.
This voicing.
Cool. Thanks.
And voicing is also actually on all our guitars. Violet series is there, and even Little Jane, our treble guitar, is there.
So it's a standard process. Manufactured.
We do it because even though it's of course extra cost, but still it's I see it as a core value of our guitars.
Yeah, okay.
So I want to have it in all our guitars.
Right. So to be better safe than sorry, right? In that case. And this is not wood. You told us.
No, this is not wood. Yeah.
It's like a micarta, or what is it like?
It's artificial material, but it's the point of having something here is that we of course don't want the strings over years to pull through the top, which is happening on guitars over years. So we don't want to have that, and but we are also like we found out this material that it's very good. It's transferring the resonance very well.
It's really stiff material, or
it's stiff, of course. The stiffness is very important for holding in place, holding the string in place. That's one thing. But the resonance transition also has to be on a high level, so it has to ring. So we have found this material too.
You see a lot of improvements in a normal acoustic guitar. Thanks, Petr. It really was a pleasure.
Thank you.
Giving us those deep insights in. Let's see the neck again for the camera one time. Philipp, come. Thanks, man. It was a pleasure. Thank you. Guys, Petr from Furch Guitars.